Hello, and welcome to this online presentation of Getting Started with Linux on TI's ARM processors. My name is Steve Preissig, and I will be walking you through both the presentations and lab exercises of this one-day workshop. If you would like to run the lab exercises yourself, the instructions and all needed software are available for you on TI's Express DSP Wiki. This workshop will give you a very basic overview of the Linux operating system, focusing on three key parts: the U-Boot bootloader, the Linux kernel, and the Linux file system. I will introduce the concept of a Linux distribution, which provides these three key elements tested together as a unit, and I will tell you which distributions are currently available for TI's various Linux-capable platforms from both TI and TI's partners. I will also provide you with an overview of these various Linux-capable processors, comparing their various performance, peripherals, and on-chip memory. After these hardware and software overviews, we will proceed into three more focused topics. First, we will describe in detail the process of booting Linux on a hardware platform using the U-Boot bootloader. Next, we will explore the concept of a Linux display manager and desktop environment, focusing on the GNOME desktop environment. These tools can be used to create the graphical user interface for your products. Finally, we will explore network connectivity. Here we show you how those objectives have been organized into the lecture modules. In the first module, the Device Tools Overview, we're going to give you an overview of TI's Linux-capable devices as well as the hardware development platforms that are available for them. Now, these devices are extremely feature-rich, which makes programming them somewhat complex. Fortunately, we have software development kits for all of these development platforms. These development kits contain not only Linux, but a number of other software packages to aid you in development, as we'll see. Next module, we'll go through booting Linux. This is primarily revolving around DOS U-Boot, which is a common Linux bootloader that's part of the open source community. After we've booted Linux, we'll go through a high-level investigation of Linux. Just what is it? What are all of the features that Linux provides? Why would you want to use Linux in the first place? Then, how do you get it? This question is primarily centered around, do you want to go with a community version of Linux, which TI supports, but which is also available for modification by the community in an open source format? Or would you prefer to go with a third party who has a commercial version of Linux that they have available? So we'll go through the advantages of both and what your decision should be centered around. And then finally, if you do want to rebuild Linux, if you need to rebuild the kernel, for instance, in order to add new features, how do you go through that process? After investigating Linux, we'll go through some more detailed, everything in the morning is high-leveled. In the afternoon, we will go through the more detailed sections, focusing on specific packages. So the first one of these is Linux displays. And we'll go through the X Windows system, which is the common display manager used for Linux. And then we'll go through a specific desktop environment, which is built on top of X Window, called GNOME. After that, we'll go through file systems and mounting. Why do you need file systems? What type of file systems are supported in Linux, specifically for the AM3517? And we'll talk through the details of how do you mount these file systems, which mounting is just the procedure by which you give access to the storage media to the operating system. And then finally, we'll go through how was the multimedia card that we used in the lab exercise following the booting Linux section, how was that created? So we'll go through some of the details of creating that card. We'll wrap up our workshop with Linux networking. This is a common connectivity concern, obviously, and one of the great features of Linux. Networking is built into Linux from the ground up. So we'll talk about how do you configure networking on the board, either dynamically or statically. How do you set the IP address, netmask, etc. Then we'll take a look at some packages. The first is the file share, Windows file share, which is called Samba. We're going to use the Windows file share so that when we get into the lab portion, we can access the file share with a Windows PC. There's also a file share service called NFS, which is the Linux version of network file sharing. And then after that, we'll get into wrap up the day with web servers. So this version of Linux that we're using has a web server called the Tiny HTTP daemon, and we'll go through how do you configure that, and then even how do you set it up so that every time you boot the board, you will automatically start the web server in the background. As we mentioned, each of these sections, or all of the sections except for one actually, has a corresponding lab exercise. These are slightly out of order. This is how we do them in the one-day workshop that's presented live, but in order to give you a better flow online, we've slightly reorganized these labs. But you can see that after the boot discussion or lecture, we'll have a lab exercise where we actually boot the AM3517 from a multimedia card, boot Linux running on the board. After we talk about the desktop environment, we are going to run through the longest lab section, which actually has 4 parts, in which we'll boot the GNOME desktop on the AM3517. We'll do it in a few different modes. If you have an external USB hub and keyboard and mouse, then you'll get a little bit more value out of Lab A, where we're just going to boot GNOME directly on the board. And if you have a USB keyboard and mouse, then you will have what is effectively a little mini desktop environment running purely on the development board with no connection from the host PC. Now, if you don't have those items available, this is why we have Labs C and D, where we are going to actually export the desktop environment from the AM3517 board to our host PC. That way, you can use the keyboard and mouse connections of the host PC to drive the GNOME desktop. Keep in mind, though, that when we do Labs C and D, the entire desktop is being created and serviced by the AM3517 board. We're using the host computer purely to drive the user interface. Then when we get into Lab 3, after we discuss file systems, we'll use the file system to play a Windows Media video file. This is actually the trailer for a movie from the 90s called The Crow, one of my favorite movies actually. And we'll play the WMV file. Then we're also going to do the take-home exercises where we're going to view video from a USB webcam and also hook up some USB speakers so that when we play the movie trailer, we hear the audio coming through those external speakers. The Lab 4 is actually the one that we're going to execute as the second lab out of these 5, so that's moved up to the front. In this, we're going to flash a spinning cube demo into the NAND of the board. Now, since we're booting from the multimedia card for all of the other lab exercises, this will not affect Lab 5. It won't affect any of the Labs 2, 3, and 5, which actually follow this lab exercise. But this will allow you to just boot directly into the spinning cube demo anytime you want off of the NAND flash on the board. And as you'll see, this is a pretty cool demo. At the least, if you're not going to run this at home, you should take a look at the demo as we run it in our online exercise. And then finally, we'll wrap up the day with, just after we've discussed Linux networking, we're going to go into Lab 5 where we play around with networking on the board. So we'll start by putting in place a permanent configuration of the Ethernet connection. We'll then configure the Samba server. Again, that's the Windows file share server. So we'll use this to expose a directory on the network, and then we'll use Windows to map that directory or map that file share. And as you'll see, we'll be able to access the files in that directly off of our Windows host PC. Finally, we'll configure a HTML server. That's the Tiny HTTP daemon. And we'll even put together a web page that will set it up to automatically, again, every time we boot the board, start up this HTTP daemon. And this web page will be available. We'll then use our Windows host PC and just standard Internet Explorer to view that web page. Again, the web page, though, being served directly off the AM3517 board.